Hello. 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 Good morning, madam. Am I audible? Hello.
Yes, sir, you are audible.
Madam is not audible. Madam voice. It seems to be some problem.
Ma'am, please mute and unmute, ma'am.
Hello.
Madam, you have to unmute. You have to unmute your mic. Hello.
Hello, sir. Audio is not.
Good afternoon.
Hello. Hello.
Madam.
Ma'am, your voice is audible, but it's quite low.
My voice is audible, 7?
Yes,
Sir,
director, sir,
it
your
is
voice is
audible.
audible.
Ah.
Clear.
How many participants are there total?
Till now 28, sir.
Huh? How many?
Hello. Hello.
Hello, madam. Your voice is low.
Hello. How to manage? Hello, Sanand.
Yes, ma'am, your voice is audible.
Can you? Yeah. Sir's voice is there?
Yes, yes.
Yes, it is audible now.
Okay, sir. Right.
How many are registered, madam?
Sir, around 150 are there, sir. Actually, still resource person has not logged in.
So let him be online, then we will
Okay.
start. Huh?
Okay, sir.
Participants also, only there are around 30 participants now.
Yeah, sir. We'll wait for some more time.
I think it is too early for him, the resource person.
Hello.
Hello, sir. Welcome, sir.
Good evening, madam.
Good evening, sir. Sir is there. Director sir is there.
How are you all?
Good, sir.
Director sir is there.
Hmm.
Hello, Lakshmatrao garu.
Yeah, hello, sir.
Hello. How are you?
Fine. How are you? The resource person. The resource person has to join. We are waiting for him. Once he joins, we will start.
It is too early morning for
Who
them,
not
sir.
joined?
Resource person, sir.
(3:30, 45). Maybe 6 o'clock in the morning.
6 o'clock.
6 a.m.
6.
For him, it is 6. 6 in the morning.
Yeah.
మా దగ్గర వర్షము పవర్ బాయ్ ఇప్పుడే వచ్చింది.
Oh, yeah. Heavy rain.
ఇక్కడ కూడా raining ఉందండి. Rain చాలా ఉంది.
It is raining heavily.
Raining in
For the past half an hour, it is raining, and no power for half an hour.
Sir, new education policy, you go through it. New education policy, NEP. Introduced by central government.
There are lots of changes.
Lots of changes, but how the things will move, we don't know.
We are in the transition period. Seven. You are in touch with him, madam? Are you in touch?
Yeah,
Hello?
we are through the mail only, we are in touch, sir. So yesterday night he was in touch. So once he has slept, he hasn't responded still.
Okay, he will join. He will.
Yeah.
Is it your new house, madam?
Yes, sir.
So you can host a party through Zoom.
Definitely, sir.
All the best.
Thank you so much, sir.
When did you shift, madam?
Sir, last week we shifted.
Last week.
Yes, sir. Last week I shifted. Exactly 1 week back.
Which locality is that, madam? What is that locality?
This is Kukatpalli, sir.
Kukatpalli.
So Forum Mall, near to Forum Mall, sir.
And the main road.
It's not exactly on the main road. Little bit deviation.
Can you call him through WhatsApp?
He's not. They are not on WhatsApp. They can come on WhatsApp.
They are not on WhatsApp.
Yeah, I'm trying to contact Mrs. Neha. She is also not responding. Probably it's too early for them or something. I'm not getting. I'll once again get in touch.
Prabhu is not there.
Who, sir?
Prabhu not joined.
Prabhu has not joined. It seems he has some work and he has gone out. That is what Dr. Soba told me. మీ దగ్గర కూడా వాన పడుతుందా?
వాళ్ళు చెప్పండి, ఇది చెప్తున్నారు.
లేదు, మీ దగ్గర కూడా వర్షం పడుతుందా అంటున్నాను.
ఇప్పుడు తక్కువైంది.
ఇప్పుడు కొద్దిగా తగ్గింది, ఇక్కడ కూడా తగ్గింది.
తక్కువ కానీ గాలి బాగున్నది. విండ్ ఉన్నది బాగా. కమ్యూనిటీస్ ఉన్నారు సార్ ఇప్పుడు ఎక్కువగా. కమ్యూనిటీ స్ప్రెడ్ కోవిడ్ కనపడగా విలేజెస్ అండ్ టౌన్స్ ఎక్కువ స్ప్రెడ్ అవుతున్నది.
Hello, sir. Shall we wait up to sir? I think sir has joined. David has joined, sir.
Good morning, or I guess good afternoon for you.
Good morning, sir.
Madam, he has joined, so you can.
Yes, sir. Mr. David has joined, sir. Welcome, David, sir.
Thank you.
Director, sir, you can start.
Okay. Good afternoon to one and all. On behalf of Methodist College of Engineering and Technology, it is my privilege to extend a warm welcome to the resource person, Mr. David Gorin, SRE Manager, Equifax, Atlanta, USA. And I also extend my hearty welcome to all the registered participants of today's webinar on cloud computing being organized by Department of Electronics and Communication Engineering. During the pandemic time, all the departments of our college are actively engaged in organizing webinars targeting different stakeholders of engineering education. I'm happy to inform that during the last 4 months, the college has organized about 12 webinars. This is the second webinar being organized by the ECE department, the first being on progressive web application development, in which more than 400 faculty and students have participated. The resource person was Mr. Sumant Chintagunta from Optum Technologies, California, USA. The second one is today's webinar. I must compliment the HOD of ECE department, Dr. Sobha, for identifying international resource persons having wide experience in industry for both the webinars. For the benefit of the participants, I would like to briefly tell about our college, Methodist College of Engineering and Technology, for the benefit of all the participants from various parts of the country. Methodist College of Engineering and Technology, approved by AICTE and affiliated to Usmania University, was established in the year 2008 under the leadership of Mr. K. Krishna Rao, who is having more than 25 years of experience in running engineering colleges. The college, with a sprawling campus of about 5 acres, is located at Abbots in the heart of the city of Pearls, Hyderabad. It is a non-minority, self-financed and co-education institution with an annual intake of 618. The college offers BE programs in civil engineering, CSE, ECE, EEE, and mechanical engineering. A new BE program in artificial intelligence and data science is being started from this academic year, that is 2020-21. In addition, the college offers CAT Camp PG program in mechanical engineering and masters in business administration. The institution is committed to impart high quality technical education in engineering and technology to the students with skills and abilities required to compete with the ever-growing needs of the industry around the world. The ultimate goal of the institute is to educate and graduate individuals who possess the technical and social competence and confidence to succeed in professional practice and advanced education, to be lifelong learners and to exercise responsible citizenship. A few of the milestones in the journey of 11 years of the college include excellent infrastructure and Wi-Fi enabled campus, competent qualified faculty, recognition of Department of Mechanical Engineering as a research center by Osmania University for carrying out PhD work. Students bagged 4 gold medals and several other university ranks in top 10. 10 patents published by faculty and students. 7 faculties are recognized as research supervisors. 8 faculty members were awarded with PhD during their service at this college. 32 research scholars are pursuing PhD under the faculties of Methodist College of Engineering and Technology. 165 research papers published by the faculty during the academic year 2019-20. 7 books published in emerging engineering areas. Faculty received awards both at state and national levels. Faculty has undertaken consultancy work, implemented outcome-based education. And the college has applied for accreditation by both NBA and NAC, and we are awaiting for the expert committee visit, as the visits are not yet scheduled due to COVID-19. ISO certified institution and have professional memberships. Many are reputed organizations, and industry institution interaction tie-up for faculty student exchange programs, summer vacation during a complete practical exposure to students in the real world. 20 MOUs in operation with industry and premier companies for technology exchange. Value addition courses through Vivekananda Institute of Human Excellence, Ramakrishna Math under MOU. Recognition by IIT Mumbai as a nodal center in Telangana for PaaS spoken tutorials. Recognition as an active college for past 3 years for NPTEL and SWAYAM courses. Blended teaching methodologies evolved efficiently, and the college is geared up for the conduction of online examinations. The college regularly organizes national and international seminars and conferences. Today's webinar on cloud computing is organized by Professor N.H. Shobha, the head of the ECE department. Professor N.H. Shobha is heading the department since its inception and is instrumental in developing the department and providing able leadership. I feel proud to inform that 2 of our students from ECE department, as a part of their internship at Pravisya, are associated with the development of a product called CDSE, Closed Distance Separation Equipment, world's first open office isolation equipment based on patented technology and design, creating 99.9% direct transmission barrier against novel coronavirus. With the help of this CDSE, there will be no need to remodel offices to create barriers to curb COVID-19 spread. The product is being marketed now by our students. In addition to this, the ECE students during this pandemic time were also associated with development of 2 more products that can detect corona and also can serve corona patients in hospitals. Coming back to today's webinar, cloud computing, it is a very important area and one of the hottest technologies with a high demand for qualified professionals. The best cloud computing employers include the dream companies like Amazon Web Services, Google, SAP, VMware, Oracle, IBM, and other companies looking for professionals in cloud computing. My appeal to the faculty is to expose the undergraduate students to the cloud computing skills that are in demand, which include cloud migration, deployment, machine learning and AI, database skills, programming languages, serverless architecture, etc. Even if some of these skills cannot be imparted as part of the curriculum, the faculty should encourage, motivate, and guide them to acquire the required skills available through various resources in order to compete for a lucrative career path in cloud computing. I hope today's webinar will expose the faculty and students to the latest technologies in cloud computing and benefit them. I once again extend my warm welcome to the resource person. Sorry, sir, it is early morning for you. We have to disturb you for this webinar, and I extend a warm welcome. With this, I hand over the stage to Dr. Sobha to continue.
Thank you, sir. Good morning, David, sir. So before I introduce the resource person, let me introduce the team from Methodist College of Engineering. We have our director, Dr. Lakshmipati Rao, sir, who just now spoke. I have also Dr. Venkateshwar Rao, sir, who is the Dean of Methodist College of Engineering. Principal could not come due to some valid reason. So let me go to introduction of the resource person. Hearty welcome once again to our esteemed team from Atlanta, Mr. David Goren and Mrs. Neha Talika, for this second webinar of international level. I feel privileged to introduce our resource person, who is Mr. David Goren, who is a dynamic, result-oriented professional with more than 35 years of experience. He possesses unique blend of proven technical expertise with strong organizational and managerial skills. He also possesses current Amazon Web Service certification in Big Data Specialty, Solution Architect Professional, Developer Associate, current Docker Certificate Developer. Mr. David has proven abilities in cutting-edge technologies, including cloud services, loosely coupled distributed web applications of 12-factor, microservices, Docker, enterprise messaging, SaaS, Java, parallel processing, object-oriented design, object relational design management, multimedia, data management, device integration, and fault tolerance, high availability. Mr. David has unbroken history of successful delivering mission-critical business solutions to the software, financial, medical, scientific, utility, telecom, manufacturing, big data, and entertainment media communities on cloud, Apple, Windows, Unix, and Linux platform. We are highly privileged with your presence today, sir, and we are looking forward for your session. I would also like to introduce Mrs. Neha Talika, who is going to join shortly, a multifaceted, dynamic woman, trailblazing academic and professional career in IT field. She has earned project management certificates on big data, advanced data architecture, master data management, blockchain certified from prestigious institute. I welcome Mr. David and Mrs. Neha for today's session. Now I request Mr. David Goren, SRE Manager, Equifax, Atlanta, to take up the session.
Thank you. Let's see if I can get my screen sharing to work here and get my slide deck up. All right, it's going to make me leave the meeting and come back, so I'll be back in just a second. we have a joke at Equifax that meetings are delayed more by the teleconferencing software than by any user intervention of any kind. There we go. All right, can you see my deck?
Yeah, visible, sir.
All right.
We are able to see you, sir.
Excuse me?
Yes, yes.
I'm sorry, I can't hear you.
It is visible. It is visible, sir.
Ah, good, thank you.
You may please convert to this slideshow so that those who are using mobiles, it will
Yep.
be.
Is that better?
Yes, yes, yes. Thank you.
Sure. All right. So as mentioned by Dr. Shobha, I am an SRE lead at Equifax. I've been in cloud computing for 10 years, Salesforce for 10, AWS for 6, and Google Cloud for 7 months. And been architecting solutions in it for quite some time. So we're going to go over why cloud computing is important and how it differs from everyone else's computing. So on-premise or doing your own. Okay, this is the joke I always hear when people hear about it. They say, isn't cloud just someone else's computers? And the reality is, at the very base level, it is. But we'll get to that in a moment. But what cloud really is infrastructure as a service. And infrastructure as a service, not necessarily the way hosting is, right? So, you know, as an example, say I decided to host my server somewhere else. That doesn't mean anything different than if I had my own data center. They would still have to ship machines there. They'd have to be unboxed. They'd have to be mounted. They'd have to be wired up. You'd have to install your software on it. Pardon me, and you'd have to have quite a few people to maintain all that. And that takes weeks and weeks and weeks or months. And we'll get to how cloud differs from that. But that's basically infrastructure as a service based on someone else's computers. Platform as a service, which is what cloud really shines in, is services that you would have to set up and maintain on your own that they maintain for you. And now that's the magic. And we'll get to that in a bit. This is where cloud really shines over normal implementation. Okay, one of the things I always love to talk about is what the real business cases are for cloud adoption, because there is actually a reality where there are certain times when it is not a good adoption. So let's take a good point of a bad one before we do the good ones. If I have, and this is a very real company called Map Digital in Germany, they send out millions and millions of email marketing on behalf of companies they work for, like Qantas and banks and so on and so forth. And their machines are literally running 24/7, 365 days a year, outputting millions and millions of emails a second. Now, it turns out that in cloud, where you pay by the second for most of your resources, that's not cost effective. So what we ended up doing for them is, for their daily workload, it stayed in their data centers. But if they ever had overflow, like around holidays or promotions for a particular company, we put their overflow into the cloud. And that was a really interesting model, because you can spin infrastructure up in the cloud very, very quickly. And then when they were done, we just took it back down again. But let's talk about what the best adoption is in the cloud. So variable workloads. Now, variable workloads is pretty much any online service you can name, because if people are interacting with it, you get variation based on time zones when people are awake. So if we were talking about a business that's just managing, say, e-commerce for the United States, then you know exactly what the window is of time that they are going to be highly active. And you know, if it's selling something that is popular during holidays, then you know when it's going to spike and when it's going to go back down. And so knowing that, that's a very good model for cloud, because since you pay as you go in the cloud, instead of all up front, that means that your workloads, costs, and your income start to go together. And we'll talk about that a little later. And then the other thing is, many companies, even if they're not in that kind of business, have things that they don't run all the time. They have reports, they have analytics that they maybe run once a month or once every week. You do QA and performance testing only when you're about to do a release. And then say you've got something like Netflix, Netflix being one of the biggest users of cloud. One of the reasons Netflix is so fast is they literally encode all their video for every country, for every device. So when you see a copy of a movie, there's really 175 copies of that movie to support all the different encoding and languages and standards and different devices, from your phone to a Wii to the stick that's stuck into your television or your smart TV. So the advantage to that is it makes their performance very high. They're trading storage for speed, but it also means they run giant video encoding constantly. But you know, if it takes an hour or 2 hours to encode the video, that's okay, right? They don't need that kind of immediacy. So one of the things that's great about the cloud is you have the ability in places like AWS to buy leftover resources from other people at a discount. And so what they do is they put their video encoding out there and they say, I'm willing to pay X number of pennies per second, which is much lower than the actual full price. And they say, so when those become available at that price, go ahead and actually use them and encode it. So it may take, you know, an entire day to get an encoding job done that would normally take an hour, but they'll pay 1/4 of what it really costs. So you see that this is a very compelling business model. And one of the things that I always try to tell everyone about cloud is, at the end of the day, it comes down to money. That doesn't matter how fancy the tools are, it really comes down to, can I get my work done at a cost-effective and quick manner? And if I can't, it really doesn't matter how nice the tools are, no one's going to adopt it, right? And the reason why cloud adoption has been so good is it does provide that, along with some other things. So let's talk about the biggest case of when you get a migration from a big company. Is, I own a data center, I paid $10 million to put it in place, I'm leasing all the computers that are in it, I'm paying for the building, I'm paying for 100 people to maintain all those servers, and I'm paying an electric bill for all the air conditioning and to power all the computers. I have desks and phones and everything that I need to be able to manage that center. And now my lease is coming up due, and I either have to renew the lease and pay another $10 million, or I can say, can I get rid of all that, take all of that debt off my books and move it to cloud and do a pay-as-you-go model where I don't own anything, I'm literally renting it by the second. And that is a very compelling model for businesses to not carry this giant amount of debt on your books, or this giant capital expenditure on your books. Now, the other thing that comes up is server refresh. And I actually had a very interesting visit once to a state authority's data center, where there were literally pallets of used old computers that they had taken out, laying on the floors while they were putting in the new ones. And those computers, which they had paid $10,000 a piece for, were now worth about $30. And because they age very quickly, right? The technology, the hardware technology advances very, very quickly. It advances faster than the software now, because computers are designed by computer. So chip manufacturing goes at a very accelerated pace. So the hardware goes stale very quickly. So if you put in all this money and you either leased servers or bought servers, in 3 years, you're going to do it all over again. And that is an enormous expense, and it takes a long time. The quickest server refresh I've ever seen in 37 years of doing this for a living is 8 weeks. That is a very long time in this industry. Most companies do not have the agility to say, I'm going to have a significant percentage of my servers offline for 8 weeks. So this becomes a very compelling model to get big companies to start down the path of going to the cloud. Okay, so let's talk about a real world example. All right, so Vans.com, if any of you are ever skateboarders, you'll have seen this site. Vans sells shoes and sweatshirts and apparel and skateboards and protective equipment and everything around skating. But if you think about it, their sales vary rather widely with both the seasons and whether or not Tony Hawk releases a new video game or a video or something like that. So they have this very spiky sales cycle, right? So if you think about it, if they owned their own hardware for their small business workloads, so it's like a normal day when things aren't happening, they'd have 50 web servers, 10 database servers, 10 servers for development and test, and 10 because you're always updating or fixing a broken server, right? So you have to have a little extra to make sure you don't fall below your lowest needs during the week, right? But under maximum load, they're about 4 times that size, right? Now, if you think about it, and remembering that it takes at least 8 weeks to get everything put into place, I can't wait to have those 200 servers and those 40 database servers, right? To have that high workload means that my data center has to be holding that maximum number all year long. And if I have that maximum number there all year long, I have to take care of those servers all year long. They have to have the latest patches for the operating system and for the web server software and for the database software and everything else. That's going to take a large number of people to maintain and a lot of number of hours of work, which you all get to pay for. Now, if you think about that, I'm paying for that when this is my cost model. So you see the green line is my costs. They don't vary, but my revenue varies widely based on month or event or something like that. So you see, now I have to sit there and try and plan using my crystal ball how much I think I'm going to earn to be able to offset that large bill that I cannot move. I get to pay that bill no matter what. If my revenue is 0, I still pay that bill, right? I still have to keep the data center turned off. Because if you shut them off, it takes a long time to spin that stuff back up again. So I have to maintain it all year. Now you see that this model for a large company is difficult, and for a small company, it's a nightmare because I have to make this enormous expenditure up front that I cannot, and assume I calculated wrong. Say instead of 200 servers, I needed 400. It's going to take another 8 weeks or more to get those other 200 servers. So you understand that by owning a data center, my agility as a business is extremely limited because I'm stuck with this flat expense and this flat deployment curve because it takes so long to get them deployed that I can't afford to wait, or I have to anticipate, or I have to buy it ahead of time. Okay. Now in cloud, where I'm paying by the second for almost every single resource, if I do it correctly, this is the model you get. So now my costs and my revenue go together. So if my business is slow, my expenses are small. If my business is fast and I need an awful lot more machinery, I have the money to pay for that machinery because I'm earning the revenue that goes against it. So this is the other reason why cloud is so incredibly compelling to a business of any size. And I'll give you another real world example. I wrote an app for a company where I was friends with some of the owners. And I wrote an app that did nothing more than do requests for temporary help, approvals for those requests, timesheets for those temporary help, and approvals for those timesheets. It's a little tiny Java app with a web interface and a database in the back. That's all it was. I had it deployed on machines in my house. Someone's got a lot of background noise. We can mute your phone. So I had 4 servers sitting in my house, which I had to buy. Each one of them cost me about $1,000. I had to maintain all 4 servers all the time to keep it up and running, and I had to pay the electric on it. Well, one of the servers broke one day, and I had to spend an entire day rebuilding it to get everything put together. I moved the entire thing to the cloud, running in AWS. It automatically scales up when payroll time comes around, which is every 2 weeks, and it scales back down again when nobody's using it. And I'm now paying about $100 a month. So if you think about that, and we'll get to managed services in a minute, I don't have to do backups. I don't have to take care of servers. I don't do any patching. I don't do any database patching, nothing. I literally set it up and let it run. And that is an incredibly compelling model for a small company or a giant company. So like I said before, this is the real dollar figure that gets people to go to cloud. Because, you know, yeah, I've been in financial industry and a lot of other highly regulated industries for a large part of my career. And, you know, their fear of moving their data into cloud is very, very high. And so for the longest time, they were very resistant. But when you come back in and you show that these dollar figures, which by the way, literally work out to about 10 to 20% of what you're currently spending when you move to cloud, if you do it properly, is so compelling to a business that they can't turn it down, because they can't go to their stockholders and say, no, I'm actually going to spend 5 to 10 times as much because I feel like it, right? So this becomes very important, which is why cloud has gotten so big so quickly. And there are some other reasons, which I'll get to in a moment, but this is the one that gets businesses to move to cloud. Okay. There's a lot of differences to cloud from data center. And this is why it's such a specialty skill and why we are in such large demand, people with cloud experience and cloud certifications. It's not, if you can use cloud just like you use your data center, and it will be inordinately expensive. You will not save money and you will not be happy. And a lot of companies that have done that have made that mistake, which is why they tend to hire people like me or someone who understands how cloud differs from on-prem to help them move forward. And that's all the way across the board, from developers to testers to financial people to infrastructure people. So let's talk about the first one, pets versus cattle. This is an AWS expression, which I don't particularly care for the analogy, but it makes a lot of sense. All right, so in a data center, my servers are like my pets. I name them, I take care of them, I pet them, I make sure that they're healthy, I make sure that they have enough power and cooling. I take care of them and I keep them for a long time, right? Cattle, on the other hand, you buy some, you sell some, you kill some, you get some more. They're ephemeral, right? And in the cloud, when cloud is done right, no resource lasts for a long time. You're always recreating it. And what does that give you when you recreate it? One of the things it gives you is, I never patch a server, ever. I just create another one. And because the one I created pulls down the latest versions of everything, it's all patched up already. I don't have to do any patching. So if I have that set up properly, as my new servers deploy, my old servers go away, I'm constantly up to date. A second thing is something that cloud providers do. They always favor the newest hardware. So when I recreate a server, it moves from the oldest hardware that it might have been on to the latest hardware. So I get the advantages of that speed and those quicker processors and those faster buses that they have. And one of the things that companies like AWS do to encourage you to do that is they will literally make the newer servers cheaper than the older servers so that they can decommission the older servers. And the advantage to that, to me, of course, is I always get the latest and greatest. I don't have to pay for it. I don't have to rack and stack, which is the whole process of buying servers, shipping servers, mounting servers, and wiring them up and installing software and all the other terrible things that you need to do, which like I said, 8-week span, I get the latest hardware in 2 seconds because I moved from one to the other. Okay. And some of the other advantages to that, of course, is if something starts to break, all I have to do is move it. And by moving it, I just recreate it. And suddenly it's on the hardware that's not broken, right? And a lot of companies like Amazon, which they're the biggest, will send you a notice to say you're on hardware that's starting to degrade. You may want to move your stuff if you're not automatically moving your stuff often. Okay, speed of deployment. One of the things that makes for speed of deployment is infrastructure as code. So if we go back to my example of building out a rack of servers, if someone actually has to log into every single one of those servers and type, yum install Tomcat, yum install OpenJDK, and then do all the configuration files and so on and so forth, to do 200 servers would take days, and it would take a large number of people. But if I'm using infrastructure as code, so I'm using Ansible, I'm using Chef, I'm using Puppet, I'm using Terraform, using CloudFormation, I can define my entire infrastructure as code with config files, no different than my Java app with config files. Now, the advantage to that is, one, I can stand up infrastructure very, very quickly. I can also take it back down when I'm not using it, knowing full well that it'll only take me 15 minutes to stand it back up again. Now we're getting into some really interesting and amazing things, because you think about it. If my QA team is doing release testing, and they do release testing 1 week every 2 months, which is fairly typical, right? Or 1 week a quarter, I don't have to have their infrastructure stood up for that entire quarter. I can stand it up 10 minutes before they're going to use it, have them use it for a week, and then take it back down. And since I'm paying by the second, now my QA's hardware expenditure is now 1/10 of what it used to be. Or I can go the opposite way. I can have them do testing I could never get them to do before in the data center, because in the data center, I could only give them 10 machines. When in the cloud, I could give them 400 machines, as long as I only give it to them for a week and not all year, right? And I'll give you an example. I used to be at the weather company. Now, the weather company provides weather data for pretty much every phone app on the planet, as well as websites, TV stations, and many things in about 30 countries, something like that. So we're managing petabytes of data and millions of requests a second. And during storms, it's actually billions of requests a second. And we ran the entire thing in AWS. We would literally run our infrastructure at 8 times its normal size during a hurricane. But because we made our money on requests, we were able to do that. Now, another example, we wanted to stand up a new feature for existing data. And one of the enterprise architects comes to me and says, well, we'd really like to do this, but it's going to take 4 weeks to try and calculate what the real throughput's going to be. And I looked at him like he had been crazy. I said, what do you mean? He said, well, we have to do all the math and we have to figure it out. We're going to run 10 servers and figure out how it'll look. I'm like, you have the real data, right? He said, yes. So I said, all right, how about we stand up 400 servers for an afternoon and we just run it and we see what performance numbers come out. And we did it. It took an hour. And at the end of the day, I think we paid $5,000 for everything we allocated, against a month of his entire team not being available to do any work to try and calculate those numbers, which they may have gotten wrong. So this is another really compelling thing in cloud, that even QA people are different in cloud than they are on-prem, because you can get away with things like that you couldn't even dream of doing if you're in your own data center. Now, let's talk about some other things. Economies of scale works in cloud just like economies of scale works in any other business. If you go to a vendor and you say, well, I want to buy 10 computers, well, you're going to pay full price. If I'm Amazon and I go to a vendor and say, hi, I want to buy 300,000 computers, they get a big discount. Well, they tend to pass that discount along to us. And the advantage to that is they're still making money and we're getting things cheaper that we would either not be able to afford at all or would not be able to manage at anywhere near the price point that we're paying when we're paying to Amazon. So this is, again, very compelling to be able to get a hold of that economy of scale that you know, especially as a small company, you could never even hope to approach. Inherited security and fault tolerance is a very big thing right now because we're doing federal secured data right now at Equifax, among other things. Securing a data center is an extremely complex thing to do, and it takes months, and you have to have security personnel and, you know, special door cards and how you manage users and how you manage building access. It's an enormous amount of things to do. And if you wanted to secure your own data center that way, you will pay a lot of money to do that. And you have to renew it every year. You don't just get it and keep it. And every country has their own standards. And even within countries, every government authority within those countries has different standards. So I understand that maintaining data center security at any high level is incredibly expensive. Well, companies like Google and AWS provide that to you for free because they already do it for themselves. So they extend it to the services they provide to you. So now you have this security that would be, again, extremely expensive and difficult on your own to maintain, and now you inherit it. So a tiny company of 2 people can actually run secret level infrastructure in the cloud and do it the same as, you know, a giant corporation could, like, you know, General Dynamics. Fault tolerance, same thing. If I tried to own more than one data center, and I've worked for companies that have done that, it's incredibly expensive to maintain the cabling between the 2 of them and all the power and the air conditioning and everything else. It's an enormous expense to have fault tolerance. And even then, they can only put them so far apart because you still have to wire them together in order to have true fault tolerance. Well, companies like Amazon and Google already provide this for you because, again, they do it for themselves. So they've just extended it to us to have that same capability. So when you're in Amazon and you're in a region may have 6 data centers in it. And each data center has got its own separate power and cooling and network connections and everything else. And is usually, I think actually the rule they have is they're at least 2 miles apart. So now, saying that, if I deploy into multiple availability zones in AWS, which I do all the time, if they have one data center go down, I'm not down. So now I've inherited their fault tolerance without me having to do anything beyond saying deploy to 2 of them. And you can expand that all the way out. You can do to all 6. You can deploy across multiple regions, and the capabilities are there. We're actually doing that right now with Google. We're deploying East Coast and West Coast at the same time. Now, Google's tools are a little less mature than AWS's, but the capabilities are still there. And again, we don't have to pay for it. And because we can spin things up so quickly, and we did infrastructure as code, you spin up everything in the East Coast, you modify your config parameters, and you run the exact same code in the West Coast, and we're deployed on both sides. That gives an agility to a department, a team, an individual, or an entire company that you really can't get in any type of data center type environment. Okay, managed services. This is the true magic. This is the stuff where cloud goes from being compelling to being really amazing. So let's talk about databases. If I wanted to run an Oracle fault tolerance database, not even Oracle RAC, we'll say Oracle master slave. So if I wanted to run an Oracle master slave configuration, I would need a minimum of 4 people to maintain it. And I don't know, 2 racks of servers. So putting that together, and of course, then I would need people to maintain that rack of servers. That's a huge expense, right? Because those servers constantly need operating system patches. They constantly need database patches. They constantly need database backups. They need database index reforming. The list goes on and on and on. And Oracle database DBAs are incredibly expensive individuals. I had DBAs working for me and I was a director and their salaries were higher than mine. And I was their boss, but that's how much they cost because that's what you need to maintain an Oracle database. Now, if I spin up an Oracle master slave in AWS, I can do it with one person in 15 minutes. And because upgrades, patching, and backups are all built in and all I have to do is request them, I'm done. Now imagine that. I need nobody. I need an hour of somebody's time to set it up, tops, and I'm done. Now that's amazing stuff, right? Because now, yes, I'm paying a little bit more per month for the service, for the Oracle database service. But when you weigh that against not having to have my personnel tied up, babysitting this database, that is very compelling because one of the things that you'll always find is that companies can never hire enough staff because it's a large expense on the books and it's hard to maintain. And so having the ability to let the cloud service provider give it to me as an operational expense instead of the huge capital expenditure of 4 employees, this is a very compelling model. And again, it allows a small company to be incredibly agile and spin up something very large. I'm running an Aurora database behind that little app I was telling you about. And that Aurora database is completely fault tolerant, very high performance, and could manage, if they told me tomorrow that they wanted to put 1 million users on it instead of the couple of hundred that are on now, it would take me 5 minutes to set it up to handle 1 million users. But imagine trying to do that in a data center. It would take months to set that up. So again, that agility is amazing stuff. So let's talk about some other things they do. They have like streaming and queuing and storage. So basically things that you would have to set up yourself. If I wanted to do streaming, I'd have to set up Kafka clusters. And again, Kafka clusters work fabulously. They are wonderful. They're incredibly hard to maintain and take an awful lot of servers. But if I can say, I just want to run streaming right now and not have any servers at all, I want to use Kinesis, or I want to use global pub sub in Google Cloud, all I have to do is say I want to use it. And then I pay by the second while it's in use. And when it's not in use, I don't pay anything. And so again, a very compelling model. Same thing with queuing, same thing with storage. Now let's talk about auto scaling. So scalability is another thing that cloud provides that you can't do it all on your own. So again, if we get back to that model where I need 50 servers one day and 200 servers the next day, if I was in data center or if I were even in VMware or vCloud, I would have to manually or run scripts to spin all that up, and I would have to get the resources from someplace, right? The machines would either have to be sitting idle or I'd have to steal it from someone else to have that capacity. But if I set up auto scaling in AWS or in GCP, and I say, I want 10 servers today, and then if my load goes up, I want to go to 200, up to 200 servers. It'll spin up those 200 servers in about 5 minutes, maybe 15 tops. How do they do that? Well, again, it's that economy of scale. Their data center has 300,000 CPUs in it. They've got room because while I'm auto scaling up, somebody else might be auto scaling down. And so the services are available. So how do they figure that out and how to get it all matched together? And I'll tell a story about that. I was holding an event at a restaurant, and the owner of the restaurant met with me and he said, well, I actually give them a reduced version of my real menu instead of like forcing them to eat like a specific meal. And I said, how do you do that? He said, well, I've been in this industry for so long, I can tell you in a crowd of people pretty much what the percentage will be of who will order chicken, who will order a vegetable plate, who will order steak. And I can estimate that in my kitchen and then be prepared ahead of time. And I looked at him and I realized that's amazing. And that's exactly how cloud works. because these companies are in the business of handling large volumes, especially ones like Amazon. Amazon Cloud started for Amazon. So they had an idea of how things scale up and down and how departments utilize things and how different industries utilize things. And so they built their cloud platform knowing that. And so the advantage is I get to leverage that for free, right? As long as I'm willing to pay per second for what I'm using, I can be a tiny company and run a giant platform if I want to, or I can scale up and down as things needed, or I can be a giant company and do the exact same thing. And the advantages to that are unparalleled because then my costs and my revenue are tied together, right? And my agility, meaning I can scale as quickly as I want in minutes and not have to worry about, oh my goodness, there's, Diwali is coming up and now suddenly I have to have 10 times my current capacity and I only have 6 weeks to do it in. Well, I can do that in 15 minutes now with cloud. Okay, other good things, data lake and analytics. This ties back to the same thing of things you don't use all the time. You don't run your analytics every day, or at least you don't run all your analytics every day. A lot of your analytics happens periodically. You want to know what's happened this month, this quarter, this year. Well, great. If I have my analytics all as infrastructure as code, I spin it up. I access my low cost storage. I bring everything that I need up to current. I run it and then I put it back and I get rid of everything. And now the advantage that is I paid very little, but I can actually run analytics way bigger than I normally would because I'm only doing it for an hour or a day. All right. Now, within that one day, it can get very expensive, but when you put that across maintaining that hardware for the entire year, it becomes an infinitesimal charge. Okay, serverless. I know a lot of people talk about serverless. Serverless is still not as mature as everybody would like it to be, but it's very compelling, and a lot of the managed services now are serverless. So things like databases. So like right now, if you want to spin up a database on your laptop or in a data center, you have to tell it how big it's going to get. And if it exceeds that size, it breaks, right? It'll just break. Whereas if I spin up DynamoDB in AWS and I say, I don't really care how big it gets, I'm just paying by the second, it's serverless to me. It's running on their infrastructure. They take care of scaling it. I don't have to do anything beyond pay my monthly fee. Well, that's magic because now I don't really have to worry about it. Now, of course, you have to be careful and monitor your expenses because someone can do something, shall we say, questionable and run your bill up, just like your child using your cell phone too much. But at the same time, I also don't have to worry about it crashing if I hit my database limit, right? And then serverless for things like web tiers. So web tiers running serverless, really nice because you don't need the kind of performance that you do for like an API, but you don't necessarily want to maintain all of the code. So the advantage and all the infrastructure. So the advantage of being able to just deploy your code as a container or as a Lambda is a very compelling model. Machine learning, this is another one like analytics. Most of the machine learning I've ever seen really uses brute force, right? In that it takes your model and it runs every variation. Well, if I'm running every variation on 10 servers, that could take a month. But if I run it on 1,000 servers, it could take an hour. So you understand that if I spin up 1,000 servers for an hour, it's probably going to cost less than running full blast 10 servers for a month, right? And I get my answer a lot quicker. And if my model's bad, I know immediately, I know in an hour. Whereas if my model's bad and I run for a month, well, I've wasted a month. So again, machine learning is very compelling in the cloud because that scalability lets you resolve models and tune models much more quickly than you can on your own infrastructure. IoT, Internet of Things. This is like big connectivity, and I do some of this work on the side. And this is being able to integrate telemetry and devices like that to the cloud to get aggregate data. And you'd be amazed of the things you can do with that. The example that got me so excited about this was a few years ago. I saw, can't remember the name of the tractor company, But giant tractor company that build these enormous planting machines, and the planting machines literally cost $500,000. And the machine had 1,000 sensors with every single planting finger, which was checking soil moisture and depth and density, and it was comparing it to GPS data to determine what the general area that it was working in was like, and adjusted planting depth accordingly. And it was doing that something like 15 times a second. So imagine the economy of scale that they got by not having to put all the processing power inside that machine, and instead had it all in the cloud, so it could be updated easily, it could be modified easily, and it could be monitored easily, as opposed to trying to update software inside this planting machine, which could be out of date, which could be having an error, and no one would know because it's on the machine itself. But via IoT and up in the cloud, you now get this much more compelling model of being able to control it more centrally. Okay. I know that was an awful lot of information in a very short period of time, so I'm hoping you have a lot of questions.
Hey, David, this is Neha. Can I start with my question?
Sure.
It's such a beautiful presentation, David. I'm pretty much impressed with everything that you mentioned, from on-prem to cloud and AWS to Google. And, you know, we connect a lot to these concepts too and working on it. So let's talk about the encryption concepts in Google versus the data that we encrypt on-prem. What is the difference there? Because, you know, when you move to from on-prem to cloud, the first question that actually comes to a lot of people's mind is about the security. And, you know, when the more we go into the digitalized form, the more cyber threats are possible. And I know you have a lot of first-hand experience in dealing with these kind of things, whether you call it like a compliances perspective or data security perspective, or, you know, many other things, FedRAMP or FISMA or, you know, MSAC. So having a first-hand experience for over 25 years, I want you to talk about that a little bit.
Okay. Very good question. All right. One of the issues that always comes up is how secure is cloud? And the reality is it can be as secure or more secure than your data center. And again, you can inherit services. So let's take a prime example. We'll talk about something I'm working on right now at Equifax. We're going to be handling data for one of the government agencies. And the data is highly secure, personal information about people that are receiving benefits or work for that agency. And obviously, we have to prove to them that it's secure in the cloud. So a couple of things happen in the cloud. So if I wanted to encrypt my data right now in, say, an Oracle database, I can use Oracle database encryption, or I can encrypt the data inside my app, put it in the database and decrypt it, come back. And if I do it right, I'm using something like AES 256, and I'm using a 256 key, and I get to maintain all that, right? So that my data stays secure. Now, one of the things that happens in AWS GovCloud or in GCP's certified environments is I can use their key management service with my keys, and they do the encryption at the hardware level. So the database persistent store, the actual SSDs and hard drives that it's sitting on, are encrypted, but it's maintained behind the scenes. So when I access it, I just see clear data, even though it is encrypted at rest. So having that encryption at rest managed by them is just one less thing that I have to deal with. Now, because it's a secure environment, we have to do some proving that we're maintaining the keys so that nobody can run away with them and decrypt the data. But that's the only thing we have to do. The actual encryption and decryption is completely out of our hands and it's managed by AWS or GCP. The same thing is for encryption in flight. So encryption in flight normally would mean that I would have to take every web server that I own and put a certificate on it and maintain that certificate, make sure it's current and make sure that web server is current with that certificate and has the right encryption algorithms on it. And those are patched up to normal patch. Again, in GCP and in AWS, and I talk about those two because they're the ones I know the best. I know Azure has this as well and Salesforce, but because I don't work with their infrastructure very much, I don't talk to them. But in GCP and AWS, I can actually use the certificate manager, upload my certificates to it, tell it what load balancers to put them on, and I'm done. I have nothing else to do. And I get the same inherited level of encryption that AWS and GCP support for everyone in secured environments. So I get to leverage theirs. So when you have to try to certify something, and when I certified things in data centers, you spend months gathering evidence and proving that you really secured everything and proving that you're really tracking everything. But when Google or AWS already has a security certification, I inherit theirs by using their tools. Again, very compelling, because a process that we're going through right now for certification that would normally take 6 months is probably going to take us a month total. And if they actually had experience doing this before, it would probably be 2 weeks. So 6 months to 2 weeks. And the number of personnel is probably 1/10 of the number of personnel that I've done for data center certifications for banking industry. So understand that inherited capabilities. And let's talk about general security. So if I wanted firewalls, I'd have to go out and I'd have to buy F5s or Cisco CSRs or, you know, whatever Junipers, whatever devices that I wanted to pay for, either software-based or hardware-based, and put them in my data center and then route all my traffic through them. In something like GCP or AWS, I can literally say, I would like a firewall, please, and I'm done. I can put the rules in the firewall. I can update them via code. I can pick their default templates that they have for different types of security options that are already all pre-built. And now I have nothing left to do. Now imagine that. I don't have to maintain them. I don't have to update them. I don't have to have people babysitting them. It's all built in. And so again, now keep in mind, none of those services are free. None of them are free. But when you weigh them against maintaining it yourself, when personnel is your most expensive thing, right? Because they have to have a place to sit, they have to have access, they have to have a laptop, they have to have all these things. And then I have to keep an eye on them to make sure that if they're terminated or they get sick or something like that, that security is properly managed. When I'm in the cloud and it's all managed by the cloud provider, I don't have to do anything. I don't have to do anything. I just have to use it and then prove I'm using it. And that's all I have to do. So, you know, Sneha, that was a very good question. That is another very compelling reason to use cloud platforms instead of doing it yourself, because you get to maintain all that on your own. And if you're using app level encryption, like some places do, well, now you have all the code and overhead of encryption and decryption. And you have the potential for libraries not being compatible. And you have potentials for libraries not getting certified or getting decertified. And you have to deal with all that, right? If they come out with a new version of Bouncy Castle and they say the old one has a vulnerability in it, you're going to get to work all weekend patching your Bouncy Castle decryption libraries all over the place, right? But if it's built in and you're using the platform, you don't have to do anything. I remember about 6 years ago when we had that whole Heartbleed SSL vulnerability come out, right? Where they found out that an encryption library that everybody used had a vulnerability that could be exploited. Every company I knew had to drop everything for like 5 days to patch everything to get rid of that library and put in one that was certified, right? So that was the big SSL to TLS switch over. which was an enormous amount of work. Now imagine that. My entire IT department lost a week of productivity. Do you know how much that cost? Whereas if we were built using AWS's facilities at the time, all we would have had to do is click the checkbox that says, yes, please give me the latest library. I kid you not, and you're done. I had a vulnerability in that app I told you I have deployed in AWS. They notified me and they said, do you want us to fix it? And I said, yes, please. And that was it. No entire weekend of patching an Aurora database. All I had to do is say yes, and they took care of it. So again, a very compelling reason, I've been a consultant in this business as well as an employee for a good portion of my career. And a lot of times the other question that comes up is, what business are you in? And if your business is not providing infrastructure, then you shouldn't be maintaining your own infrastructure. That's really the bottom line. You shouldn't be doing something that has nothing to do with your business. If your business is selling skateboards, then you shouldn't be maintaining infrastructure, because it gives you no profit. It does not move your business forward in any way, shape, or form. It's just an expense of keeping the lights on and getting your business done. So if I can offload that to someone else, that is an extremely compelling model.
Excellent point that you have touched, David. Thank you. So you talked about the internal vulnerabilities and how one needs to handle. And you working for Equifax, do you think the recent breach that happened is due to any of these vulnerabilities, and it is of course it is a lot more beyond that, but do you think this also might be one of the reasons for the biggest security breach?
Okay, let's tell tales out of school. I'm assuming it's public enough knowledge that I can actually talk about how they got breached. Remember, I was talking about one of the things that is a very popular concept in cloud is called immutable infrastructure. Mutable infrastructure means I never update it, I just replace it. And like I said, if you're running infrastructure as code and it always pulls the latest, I never have to worry about anything. So let's go back to so back in 2017, Equifax got breached and they lost quite a bit of data. And how they got breached was one of their subsidiaries, which had access to the data, had a set of servers that were very old and not patched. And they found a vulnerability in the operating system of one of them, and they connected in, they took their time, and they used it to gain access to the entire network. And eventually they downloaded 500,000 people's identities. And keep in mind, Equifax has your financial history, your social security number, your bank account balances, your addresses, all kinds of information you wouldn't want out in the street. And it all disappeared because of one server that wasn't patched. So if you think about it, and it was a server nobody even realized should have been patched. So they literally almost ruined the entire company. Multi-billion-dollar company destroyed because of one server in one subsidiary that wasn't patched. So this is one of those things where, again, being in cloud where security is pervasive is one of the things that's fun about infrastructure as code and being able to handle infrastructure at the programming level is we make rules that you're not allowed to deploy things that are vulnerable, and that we monitor. So if anything vulnerable is deployed, we can get rid of it and create another one. So having that model, again, gives us a sense of security that we would not have if we were maintaining it ourselves. If we were maintaining it ourselves, we would have to have extra personnel to make sure that all the servers are updated. And right now, because I maintain one of the legacy apps for Equifax that's running in data center, I have one employee out of 6 where 90% of his time is spent doing patching for the on-premise data servers. Now, that means 1/6 of my resources are now unavailable to me because he's patching servers, when I could really use him to help move the business forward. and instead he's, mopping the floor, the equivalent of mopping the floor. But it's necessary because there's no automatic way to patch those servers in the data center. Now, don't get me wrong. You can implement things like Chef and private cloud and things like that and get that same level of automation that cloud has inside your own data center. But, again, that's like, why would I try to hand build a Ferrari when I can just go rent a Ferrari, right? This is the model that you come back to. Of course, you can do it yourself. Cloud, there's no magic in cloud. Now, this is a joke that me and some of the other technical architects have, is that when you see DynamoDB is Couchbase. You can download Couchbase and run it yourself, okay? Their streaming is based on Kafka. Kafka is open source. You can download Kafka and run it yourself. But try to maintain it. Try to keep it patched. Try and keep it secure. That's a lot of work. I'd rather pay somebody else who's doing economies of scale because they're maintaining thousands of Kafka installations, not just mine, and leverage their much broader base. They're much more hardware. They have a lot more experienced people. They have people that specialize in Kafka. They have, because they work with many people running Kafka, they may see something that my company won't see or we don't know about. So those leveraging that economy of scale all the way across the board is extremely compelling versus trying to do it yourself.
Very wonderfully, you touched the concept of vulnerabilities, and also what Alex does. You did really explain it very well. One other question. So let's say we have a cluster and we have deployed our applications in the cluster, and then you have given access to a bunch of people to that cluster. So will the access to the personnel will be at the cluster level or application level or data level? How does that work? Because multiple people will be working in the same cloud at a company level.
Well, let's talk about security in general. So one of the other things that cloud provides is a term called security in depth, right? Back in the bad old days in data center, and you'd be amazed at how many places like Macy's that have been breached because they have perimeter only security. So perimeter only security, right, means your security is only around the outside. So if somebody gets in, they have access to everything, right? And again, that's what happened at Equifax, and it's what happened at Macy's when they got breached, because Macy's didn't encrypt anything. They didn't encrypt any of their transactions on disk. They didn't encrypt them in transmission. And so as soon as somebody breached one store, they had access to every credit transaction that store had for an entire day. Everyone's credit card, you name it, right? Because none of it was encrypted. Security in depth is, kind of as Sneha was alluding to, is that at the perimeter of my cloud environment, I have all my firewalls and so on and so forth, and I limit ports, and I can whitelist what entities are allowed to connect and how they're allowed to connect. So if someone's allowed to connect to a cluster, they can only do it from certain locations or from a VPN. And by doing that, I now immediately exclude anyone who's not an Equifax employee, right? They can't get to it because they don't have the right tools to even touch that cluster. Then on the cluster itself, I can have permissions at the cloud level saying that this particular resource is only accessible by this group of users. So again, even if I'm in and I'm an Equifax employee, or I'm using an Equifax employee's equipment, I still don't have access because I'm not in that smaller list that's allowed to access that. Then if you're talking about something like Kubernetes, Kubernetes has its own role-based access built in as well. I can make it even further that says these namespaces are only accessible to these particular users. And so now, as Sneha alluded to, I have security in depth because I have to be an Equifax employee just to get in the perimeter. I have to be a member of that cluster to get to that cluster, and I have to be a member of that namespace to get to that namespace. So that's an awful lot of layers I have to get through to actually get to something I might want. So as a hacker, I might get one of those, but I won't get all of them, right? It's very unlikely I'll get all four, right? And that's called security in depth. And that's a very big concept in cloud. Now, again, you can do security in depth in your own data center. It's a lot of work. In cloud, it's all built in. You just have to leverage it. Yes, good question, Sneha. You're hired.
Thank you, David. So I got the job on weekend then with you. Hey, the other question is AWS versus Google. I know you have expertise in both, but which one do you personally prefer?
You're going to get me fired, you know that.
No, it's off the record, I promise.
Okay. AWS is way bigger and it's way more mature than Google Cloud.
Yep.
Which is kind of funny when you think about it, considering Google's such a huge company. Let's talk about maturity. So AWS actually began in 2006. And it was done, like I said, Amazon saw a need because they're Amazon, right? So their various departments that sell things are very prone to business going up and down based on seasons and holidays, and whatever particular thing they're selling has a huge tie to day of the year. And so what they found is that their own data centers were not being cost efficient because, if one group had 200 servers allocated, but they're only using those 200 servers 5 days out of the year. And the rest of the time they're using 50. So internal to themselves, they created EC2, which is compute, and S3, which is object storage services for themselves. And they kept expanding it. And then about 2010, 2011, they said, wow, this is really fabulous. Other people might want to make use of this exact same capability. Why don't we form a company that does that? And that's when AWS was born and out to everyone else. So you understand that AWS is, 14 years old compared to GCP, which is probably half that. So in breadth and depth of services, AWS is much bigger. And in sheer capacity, they're about 10 times the size of everybody else. And the reason they are is that for the first 10 years that they were in business, they literally poured all their profits back into more infrastructure and more managed services. And so they have a lead on everybody else that I don't think anyone else will catch. Now, so saying that, I think they are the best all-around tool. However, because they're the best all-around tool, they're not excellent in any one category. Most businesses don't need excellent in any one category. They need general workhorse. They need to be able to do web services. They need to be able to do analytics. They need to be do this. And none of it at some giant scale that would be hard to maintain. Now, if you talk about something like GCP specialized in a much smaller group of services, and they oriented their work toward a particular set of business cases. People that want to do containers, people that want to run Kubernetes, and people that have, good basic business apps and good basic business needs. And so in that respect, GCP is good for what it does, but it doesn't have the breadth of tools of AWS. And because I'm one of those people that hates being limited in anything I do, I like AWS better because if I need something, the tool is there and I can just pull it in. Whereas in GCP, we've ended up writing things that on our own that I could have just leveraged in AWS. And that's aggravating because that gets back to that model that Equifax is not in the infrastructure business. I shouldn't have to be building that myself. I should just be able to leverage it. So in that respect, I have GCP is a good platform, but AWS is a better platform. GCP is easier to use. AWS is more powerful. Now, let's talk about Azure just for a moment. Azure has its place in the world. If you're a .NET shop and you want to have to not have all of your .NET Windows people start learning Unix, GCP and AWS are very heavily Unix based, which of course 95% of cloud is Unix. Obviously, or of the whole internet is Unix. So it would make sense that cloud providers are mostly Unix as well. But if I had a .NET environment and I want to be able to function and not have to retrain all my people, you can run .NET and AWS, and I have multiple times. It does work. The learning curve for people who are not used to Unix is very high. That's the case where Azure actually works, because the Azure services that you use on-prem or on your laptop are identical to how you use them in the cloud. And the advantage to that, of course, being you get that seamless deployment. So in that respect, I can look at it and say, Azure is a good platform for what it does. Similarly, Salesforce. I've been working in Salesforce for 10 years doing integrations. For what it does it very well, and I wouldn't want to go anywhere else if I was trying to do sales marketing and integration to business customer management systems. Salesforce works, which of course why Salesforce is so popular. By the way, Salesforce runs on AWS, so to give you an idea, they used to run on their own infrastructure. And they kept running out of machines, so they actually run on AWS. So little dirty secret. But yes, so I mean, so it's the best general tool for the job is AWS, but there are specific providers that are going to give you things. And I think in the future, you're going to see even more of that. You're going to see providers that specialize in, machine learning or specialize in video encryption and things like that, video encoding. But for the best general purpose, AWS is still the top.
You did a wonderful explanation, striking a balance between job passion and the technology. You really have to appreciate this, David. It's a very, very.
Well, I mean, I'm a big fan of right tool for the job, right? Because, let me give out a little dirty secret, right? Everyone thinks Kubernetes is amazing. I've been working in Kubernetes for about 4 years now. And I have to say that Kubernetes is way overkill and way more complicated than it needs to be, especially in cloud. Okay, so Kubernetes, it's the new shiny toy and everybody loves it and everyone likes to implement it. And we're actually implementing it at Equifax. But if I had to match the business case against using Kubernetes or not, the answer would be not. Even in a place like Weather Company, where our volume and scalability is so amazing that they wrote white papers about it, and we would do presentations at reInvent about it, because we would scale from 1,000 to 8,000 to 10,000 servers in a day. Absolutely unbelievable scalability. You would think that Kubernetes would be the way we would go, and the answer is no. Kubernetes was a poor choice. And the reason it's a poor choice is because Kubernetes adds a lot of extra layers, and each one of those layers adds complexity and latency. And if you're trying to be fast and you're trying to be agile, Kubernetes will slow you down. And so in a lot of scenarios, if I was in a data center and I needed the capabilities similar to cloud of vertical and horizontal scalability, yes, I'd use Kubernetes. But when I'm already in the cloud and I already have scalability, I don't need it. And so this is where I say, stick to a less complex container manager. And at the bottom line is, container management really is to handle deployment and dependencies. So if you actually have good dependency management and good deployment standards of your own, you don't even need containers. So those are the kinds of things that like frameworks like Spring and React and Django and things like that, they're actually covering for bad practices. So I look at this and I say, all right, you're trading complexity and hardware at the infrastructure level to compensate for developers doing non-optimal things. So I'd rather say train your developers better in 12-factor and in proper apps and in services and use less infrastructure, right? Because in the long run, it'll keep your costs down and your code will be more agile.
Oh yeah, and we know that the cubes is over-engineered and underutilized, especially in Google's. Yeah, got it. One last question before I switch, things to Shobha and her team. So let's say if we have our data on AWS and company has made a decision to migrate from AWS to Google. So how easy it is, how hard it is, what kind of framework and architectural challenges that we like to face?
Okay, so to migrate from AWS to Google?
Yeah.
Okay, all right, well, again, there's a lot of equivalencies between tools. And this is where, and because they're all based on the same open source, right? So you have to remember that, if I wanted to go from DynamoDB and AWS to Bigtable in Google, they're both NoSQL databases. Yes, they have some variations. Keys are a little bit different between the two of them, right? But there's nothing saying that with a little bit of planning, I couldn't just dump the data out and say the data is enormous. So I could just go and get a Snowball, and a Snowball is a little armored case with disk drives in it that you send to AWS. They load the data on it. They send it to you. You send it to Google. Google loads it up, and you've moved your, terabytes and terabytes of data. Or I transmit it over the internet, right? Depending on the actual size. But the reality is you can, because they're both based on the same open source NoSQL technologies, there's a lot of equivalencies between the two of them. And you could write or use an ETL tool to dump it down and load it up, okay? There's also nothing stopping you from doing synchronization. You would have to write a little tiny app in something like Python or Java or Go, and you could move the data over. So there's an awful lot of equivalencies between all the cloud technologies and open source. So never fear like you've cornered yourself because you're using Kinesis. Well, Kinesis is based on Kafka. You can download Kafka and use it yourself. So you could use the exact same technology. And in fact, when I was at a certain giant telecom that might start with a V, they bought a company that was doing just that. When they originally started, they wrote it all using Kafka. They were processing security analytics on millions and millions and millions of network packets a second. And they used Kafka clusters. Well, they looked at that and they moved it to AWS, and they realized that maintaining those Kafka clusters was taking up a giant amount of their time and money. And so they looked at it and they said, well, I could just as easily migrate that to Kinesis. And because the concepts in Kinesis of sharding and how transactions behave is identical to Kafka, it was not a big deal to make that move, right? And so that's what you're going to find. Now, I'll put a caveat in there. Cloud, no different than data center. If I tried to move from a SQL database to a NoSQL database or back, that's hard because architecturally, the data is organized in a very different way between those two, right? So those concepts you have to think about.
Yeah, definitely. As long as there is compatibility, of course, with writing some synchronization apps, with a little bit of changes, I think it is doable, easily doable. One thing is like, if somebody is in engineering college, like the students that you are addressing, they don't know where they are going to end up. They may be ending up in QA space, QA space, or they may be a product owner down the lane, or maybe developer or some other role. So do you advise them to do at least a foundation certification so that their opportunities will be doubled at the time of hiring? Question number 1. And question number 2 is, how important for the fresher to get exposed to these technologies, at least the very basics, because these may or may not be part of their syllabus. Sometimes, I don't know what the syllabus is right now, but whatever that we use in the industry are not always part of their curriculum, unlike here. So what is your recommendation for them?
Okay, very good question. Okay. First, yes, a certification, a quality certification like AWS or Google have, will set you apart from your contemporaries. So way back in 2014, when I got my developer certification in AWS, I was working for Amazon. I was working for an Amazon subsidiary. It still set me apart to have that certification when others did not. So I do recommend that you take the time and go through one of the certifications. There are plenty of courses online that are inexpensive by places like Udemy, where you pay $12 American to go through a 6 or 7 hour course, or actually I think the one I just went through was like 12 hours, that will give you the foundation to get going. Also, there are quite a few videos posted by Google and Amazon on YouTube for free that are sessions that they recorded that will help you learn this. And yes, the certification exams are at the lower level, they're somewhat difficult. At the high level, they're very difficult, but they are worthwhile. And, I have three advanced certifications right now, and I'm working on my 4th advanced one. It sets you apart, and it's good. It could let you know what you're doing. Now, the second thing, AWS and GCP offer free accounts for a year. They're not completely free. They're free if you use the free resources. So you can't spin up anything gigantic, but you can spin up a lot of things. So like right now, I have a free GCP account because there are things that Equifax won't let me do that I'm trying to experiment with. So I'll experiment my own account for free. And then I'll bring it back to Equifax and say, okay, now that I know what I'm doing, this is what we really need to spin up. So you can use AWS or GCP for free as long as you watch yourself, and it'll tell you if you're about to spend money. And actually spin things up live, which is great because you get hands-on experience. Another thing is you can use Quick Labs. Quick Labs will spin up infrastructure on AWS or GCP through the course itself that you're taking. And again, the courses are not terribly expensive. They're like $30. And $30 to be able to actually do hands-on standing up an EMR cluster running Spark for data analytics. I mean, that would cost $13,000 if you did it yourself to spin up a cluster like that. I kid you not, and I've done that. And you can get a rather stunning bill, but you can learn it basically for free, and for very little money. And I will say it'll set you apart. And then, of course, when you get that first cloud job, having cloud experience on your resume will set you apart from everyone else. One other thing that you might want to learn is 12-factor app. If they're not teaching you 12-factor, go look it up, understand what the principles mean. And what 12-factor is, it's really just 12 bullet points that says an app should follow these following guidelines. And those guidelines are incredibly important because that's what makes a scalable app in the cloud. If you don't do that, if you create apps that are incredibly stateful, or if they're monoliths, or if they're too decomposed, or if they don't have good monitoring and don't have good security, they will not fit well in the cloud. But if you follow 12-factor principles, you will be able to deploy apps in the cloud or on-prem and have them be superior to anybody else's apps. And so I highly recommend you know what 12-factor is. It's not hard to learn. Okay, and all these are published, right? This is not, you can find them on the internet and just download the white papers and things like that. There's no cost to you. But I think that'll set you apart, just because those are important concepts to know to be able to work in the cloud. And then, you know, like for AWS Cloud Practitioner, which just gives you a working knowledge of what all the components in cloud do, is a really nice certification to have for anyone. For developer, go ahead and get the developer certification. And so, you know, obviously I did mine in Java because I'm a Java developer mostly, but you know, you can, any good programming language, you can take that certification and still be okay. And the certification costs, I think, for students are actually not expensive. It's less than what we as employees have to pay.
True. So in the new pandemic situation, you know, instead of asking the students to come to the labs and work on on-prem servers, even the department can set up their own cluster and conduct hackathons. They can ask the students to do their academic projects. You know, a group of team members, they can set up their infra on cloud, and they can actually host their apps, and they can run. And you know, it's a wonderful tool if they can explore more further, right?
Yes. Yes.
I think I asked a lot of questions. I think
Yes,
you
you
need
did.
another cup of coffee. I make it up on Monday. Shova, I think I'm done with all my questions.
Thank you very much, Sneha. So any students, if you have questions, please, you can go ahead. Anybody, any participants? Questions from participants are invited. Director, sir.
Yes, madam.
Sir, any questions from your side?
No, I would like to just add to what Dr. Sneha said regarding the students. And madam, I would like to tell you that in computer science engineering, the technologies required for cloud computing are already part of the curriculum, and whereas for other branches, it is not included. So in case students from other branches are interested in making a career in cloud computing, we are advising them accordingly and asking them to take some courses under NPTEL, SWAYAM, offered by AICTE and MHRD, and also Government of Telangana under TASK program. It is organizing training programs for the students on cloud computing, and hands-on experience also students are gaining, and they are going for some internships also. And in this way, our college is encouraging our students to take up careers in cloud computing. So on behalf of the Madras College of Engineering and Technology, I would like to thank, in fact, Dr. Sneha for initiating the question session. And in fact, the question session is more than the presentation, and that's how we're all benefited both by the presentation and also the question session followed by that. So now it's for Dr. Sobha for proposing vote of thanks.
Thank you very much, sir. On behalf of the Methodist College of Engineering, I extend heartfelt appreciation to our resource person, Mr. David Gorin. We feel this was one of the best experiences to learn live from an expert. And these days, we often see certification courses and advertisements about cloud computing, since it is being the latest technology. Hence, this session was an exceptional informative session. Thanks for sharing your vast experience, sir. Can you kindly mute your participants, mute your mics, please? Hello? Hello, am I audible? I extend my heartfelt thanks to Mrs. Neha for her excellent questions and also recommendations for the certification courses. Lots and lots of thanks to you, Sneha, for being the backbone of this webinar. I also extend my big thanks to Mr. Krishna Rao sir, our correspondent, Lakshmipati sir, our director, Venkateshwar sir, dean, and also Prabhu sir, who has always been with us in each and every event and also in our success. I thank the moderator, Mr. Maharshi, Sanand, and the faculty of ECE and other departments of Methodist College of Engineering, Hyderabad. Last but not the least, the participants. Thank you all. You were really amazing participants. Thank you very much, Sneha, and also David. That was an excellent day for us. Thank you very much. So we close the day and we close the session. Thanks to all the participants.